ANOVA tests are used to check if results from experiments are significant or not, or in other words, whether the null hypothesis can be rejected or not. To calculate ANOVA, you need two things: sum of squares within groups, or SSW, and its degree of freedom, and number two, sum of squares between groups, or SSB, and its degree of freedom. Let's imagine that we want to compare how many cups of coffee people drink per day in Finland, India, and the USA. Is the difference between the groups significant or not? In an attempt to test this, let's say that we've gathered data from 5 people from each of these countries. The participants from Finland answer that they drink 3, 6, 5, 2, and 7 cups of coffee each day. The participants from India answered that they drink 2, 1, 0, 2, and 4 cups of coffee each day. The participants from the USA answered that they drink 3, 5, 1, 2, and 3 cups of coffee each day. The sum of squares within groups can be calculated in 4 steps. Step 1. Calculating the mean for each group, which is 4.6 for Finland, 1.8 for India, and 2.8 for the USA. Step 2. Square the difference from the mean for each observation. Step 3. These differences from the mean are added together, which is 7.2 for Finland and 8.8 for both India and the USA. Step 4. Finally, these sums are added together, which equals 34.8. The sum of square between groups can be calculated in 3 steps. Step 1. Calculate the total mean, i.e. the mean of all the samples, which is 3.07. Step 2. Subtract the mean for all of the samples from the mean of each group and square the result. Step 3. Finally, add all the squared means together and multiply it by the number of observations in each group, in this case 5, to get the final result of 20.13. Now we can calculate the F ratio in 3 steps. 1. Divide the sum of squares between the groups by its degrees of freedom, which is the number of groups minus 1, or in this case 3 minus 1 equals 2. Step 2. Divide the sum of squares within groups by its degrees of freedom, which is the total number of observations minus the number of groups, or in this case 15 minus 3 equals 12. Step 3. Now the F ratio is simply the ratio between these two numbers, so 10.07 divided by 2.9 equals 3.47. This is written as F bracket 2, 12 equals 3.47. To check whether or not this result allows us to reject the null hypothesis, we check a F distribution table. The critical value for F bracket 2, 12 is 3.89. If our F ratio is larger than the critical value, the null hypothesis can be rejected. So in our case, the difference between the 3 different sample groups were actually not statistically significant, as the F ratio is less than the critical value. I also have to recommend the online ANOVA calculator, which you can find a link to in the description. If you want to learn more about statistics, check out this playlist.